Hello, I'm John Coleman from ApocatastasisInstitute, an Institute for the Humanities and Alternative College and High School here on New Milford, Connecticut, USA. This recording is our series almost a year now. If we're not a year, we're a year shy of a week. Euclid Today, as we make our way through this 3,300-year-old math explanation textbook. I don't know if that's an anachronism, but we are on Proposition 26 today, each one building, as math is so good for, building on the previous concept. And just one announcement concerning apocatastasy says we're about to plunge hell for leather, to use an old expression, hell for leather into the autumn semester. And that is our project. And this is our integrated humanities curricula over 2 years. So this is our top shelf, if you excuse the vulgarity, our top shelf product here at Apocatastasis's. It is the presentation of all human life in a very organized symphonic fashion over 2 years. That is to say, when we're studying history from, 3,300 years ago, let's say, our literature focus is on the same time period, our philosophy focus is on the same time period, our art focus beyond literature, I will say our plastic arts focus is on that same time period. The same with, the time of Caesar, the same with the time of Charlemagne, all the way up to today. This is the project. This is the synchronized teaching of the humanities, and we have a special page for that. It's a great work. It's a big work and great in other ways as well. Anyway, the semester is going to be starting soon, and I bring that to everyone's attention. With that being seen to, Adam, welcome. Hope you've been well, and bring us up to speed on Proposition 26. I will be playing Vanna White tonight and dutifully scrolling. Take it away, Adam.
All right. This proof is going to be actually a classic proof. If I'm not mistaken, it's the ASA proof. Basically, if we have two angles that are equal and one side that is shared, we have one side that's also equal to between two triangles, then the two triangles are going to be the same. And so this is a pretty lengthy proof, but it is manageable. So let's go ahead and walk through it. All right. John, it might be wise to scroll down to the triangles. Yes. There we go. That's good. All right. Give me a second to adjust my screens. All right. So what we're going to do is we're going to assume we have these two triangles with ABC and BCA both equaling DEF and EFD respectively. And then we're going to let them also have one side equal to one side. The first one we're going to start with is assuming that BC equals EF. The remaining sides must equal, namely AB equaling DE and AC equaling DF, and the remaining angle must equal as well, BAC and EDF. If not, then one of them has got to be strictly bigger than the other. So let's suppose that AB were bigger, hypothetically. We're going to make BG equal to DE and join it. Since BG equals DE and BC equals EF, the two sides GB and BC equal the two sides DE and DF. Sorry, DE and EF respectively. And the angles also match. The angle GBC equals the angle DEF, and therefore the base GC equals the base DF. The triangle GBC equals the triangle DEF in every respect. And this all comes from Proposition 3 and 4, Postulat 1 and Common Notion 1. And the remaining angles equal the remaining angles, and so on and so forth. Okay, therefore the angle GCB equals the angle DFE. I'm mostly reading this because thankfully the argument is somewhat straightforward, even if it's a bit of a doozy. Yep. And since DFE equals angle ACB by hypothesis, the angle BCG equals the angle BCA. The less equals the greater, which is impossible. So basically, we just did a proof by contradiction. So therefore, AB is not unequal to DE, and therefore equals it. And since BC also equals EF, the two sides AB and BC are equal to the two sides, and therefore the triangle's equal. The angle's equal, and the triangle's equal. It's a proof by contradiction. That's basically what we assemble, and we're really heavily relying on proposition 4 to do this. It might be wise to refresh proposition 4. It's letting us do it away with all this, and that is that if two triangles have two sides equal to two sides and have the angles contained by equal straight lines equal, then they also have a base equal to the base. The triangle equals the triangle, and the remaining angles equal the remaining angles respectively. Basically, if two triangles have two sides that are equal respectively, and the angles contained by the equal straight lines are equals, then they are equivalent triangles. So we're relying on that pretty heavily to make this argument. All right, next, let's suppose that our opposite side angles be equal and AB will equal DE. Okay, so we're using the left line is going to be the equal one rather than BC equaling EF. Okay. If BC is unequal to EF, one is going to be greater. We're going to go ahead and again construct a proof by contradiction. Let's suppose BC is greater. Make BH and EF equal, and then again create this triangle ABH. And we're basically going to run through the same thing. We're going to construct a triangle. It's going to turn out that that triangle is going to be equal to the blue triangle, and that's going to create a contradiction. That's going to set us up for a contradiction. Since BH equals EF and AB equals DE, the two sides AB and BH equal to two sides DE and EF respectively, and they contain equal angles. Therefore, the base AH equals the base DF. Okay. The triangle ABH equals the triangle DEF, which is what we just built. And the remaining angles equal each other, and therefore the two angles equal each other, BHA and EFD. But the angle EFD, if you recall, is equal to the angle BCA. Therefore, in the triangle ACH, the exterior angle BHA equals the interior and opposite angle BCA, which is impossible. And this is relying on proposition 16 that we also proved earlier. It might be best to also review that because we've also used proposition 4. Proposition 16 says that if in any triangle one of the sides is produced, then the exterior angle is greater than either of the interior or opposite angles. Okay. And so the exterior angle of a triangle equals the sum of the interior opposite angles. That's basically what we're using here. Therefore, BC is not unequal to EF and therefore equals it. But AB also equals DE, and as a result, using the argument we just constructed above, the two triangles are going to end up being equal. That's basically a summary of what we just proved at the top there, using proposition 4. So this whole argument is pretty straightforward if you break it down step by step slowly, one at a time. It's not that hard to understand how we go from A to B to C, but it is a bit of a chunky boy. It's a longer proof than what we've been covering up to this point. And the second part also relies on proposition 16, something to note. And that's
Right.
it.
Good, good, good. Well, thank you for that, Adam. And by the way, this website that we're using, very simple website, but like a lot of these older websites, they pack a punch. This is from alpha.clark.edu. I will put this in the description down below. You can access it, and it will have a lot of these cross references. You'll see these
Hmm.
this text on the right of the screen, or at least on the right of the presenter screen. Uh, that will do the cross references and makes it easy. All the references Adam gave, as well as some translation points they bring up down below. Adam, as we knock off here, would you tell us what sorts of tutoring are you available for here at the Institute when it comes to mathematics?
Oh, sure. Like I said, my main shtick is going to be to help parents level up their mathematical skills. That's the main goal. While I can tutor anybody at any level within my knowledge base, I mean, I don't know everything about math, but I am fairly educated in it. I can provide that tutoring. So anything from K through 12 all the way up to high school, to college, and everything in between. Um, my focus is primarily on adult tutoring or high school tutoring. Um, that's where I would excel.
Good man. Very good. So anyone who's interested in that can contact us at ApocatastasisInstitute at AOL.com. And incidentally, whilst Adam and myself are quite comfortable normalizing nudity, the classes need not be in such a state of dress or lack thereof. So we
Mhm.
are very, very flexible in that regard. In any case, to the audience, thank you for your attention on this exciting journey. It's very systematic. It's dry, but it is rewarding. It is rewarding, and especially Adam, as we're coming up to our first year of doing this, thank you especially for very cheerfully donating the time and expertise to help us
My pleasure.
appreciate mathematics.
Mhm. My pleasure.